To keep it simple, let's say our system under test on-prem consists of a server responding to API requests behind an API proxy such as Apogee. The API front end needs to be set up first because it authenticates requests based on pre-assigned tokens provided to those who call the service. We'll use several types of tokens. We generally use tokens with a lot of credit for stress or soak testing. We also need one with no credits to test rejection mechanisms, and an automated way is needed to reset tokens after each test run. A monitoring agent on each server, such as Dynatrace or SignalFX, collects various metrics for display on a dashboard. Now we can begin to construct JMeter scripts that impose artificial loads. From a laptop, we can only impose a limited load, but that's okay because we use laptops just to craft scripts. Once viable, the scripts along with associated files are pushed into a private version control repository such as AWS Code Commit. Within security-conscious enterprises, instead of downloading installer packages from the internet, it's safer to obtain installers that have been vetted by security specialists before being made available from a private repository such as Artifactory or Enterprise Docker Hub. A lot of work is needed to vet the many dependencies for those who prefer to build machines from the ground up, using configuration as code, a practice that enables them to quickly respond to issues by being able to quickly change anything on the tech stack. To make use of the Amazon cloud, on the laptop we install the AWS CLI and associated tools to craft CloudFormation files that instantiate services such as EC2 to run servers within the AWS cloud. Within AWS, we instantiate images containing JMeter using common scripts in the code repository. Before we run, we should lint and audit the containers using various tools. When we need to add more JMeter instances to impose a heavier load, we can use a JMeter master to coordinate the Jenkins slave nodes. The master starts a fixed number of nodes to test app auto-scaling mechanisms. When configuration settings are under version control, changes can trigger CI/CD to automatically initiate test runs. If the analytics system has enough history, it can recognize trends, and if anomalies are identified, issue alerts while the changes are still fresh in the mind of the person who made the change. Because network traffic between on-premises servers and load generators in the cloud is subject to significant variability, it would be ideal to have a load generator near each machine under test, but it can be problematic going through the corporate firewall. It can be easier to make use of a web-based SaaS service such as BlazeMeter or Flood.io. With them, we just upload a script and they handle the rest, such as configuring enough machines. When servers on-prem are transitioned to run within a cloud, we would avoid issues with firewalls and avoid charges AWS imposes for data leaving AWS. Next, we'll look at configuration settings for the cloud, such as AWS affinity groups, to specify low latency between servers in the same availability zone.